Good evening, everyone. On behalf of the Royal College Computer Society and the Old Royalist Engineering Professionals Association, I warmly welcome you all to TesserX Workshop 2, Session 2, and Axis Initiative 2025. We are truly excited to have you with us this evening as we dive into the world of web development. To officially kick off today's session, I'd now like to warmly invite Sanidhu Lakshan, Chairman of Royal College Computer Society, to deliver the welcome speech. Over to you, Ayya.
Good evening, everyone. It's a pleasure to welcome. It's a pleasure to welcome you all to the second workshop of TesserX, an initiative of under Axis 2025, and proudly one of the first large-scale student innovation organized by Royal College Computer Society and all Royalist Engineering Professionals Association together. TesserX is more than just a competition. It's a platform designed to ignite creativity, build real-world tech skills, and help students to become problem solvers of tomorrow. With a multi-phase structure, it allows participants to go from idea to working prototype, with guidance, mentorship, and plenty of opportunities to grow. We already had an incredible response, with many teams registered and only a limited time left for new register time. One of the most exciting features of TesserX is the mentorship provided once your proposals get selected. You won't be walking this journey alone. You will be guided by industry professionals who will help you shape your ideas into impactful solutions. The grand final, including the final presentation and the awarding ceremony, will be held in Axis 2025 event, giving you a chance to present your work on a prestigious platform and compete for an exciting prize pool. As part of our support for you, today we bring the second workshop focused on web development, a critical skill in building and presenting your solutions effectively. We are honored to have Mr. Akila Induranga, a software engineer at WSO2, conducting today's session. His experience will no doubt provide valuable insight to you. With that, I wish you a productive and inspiring session ahead. Let's make the most of this journey together. Thank you.
Thank you, Sanidhu Ayya, for that wonderful introduction. We now move on to the highlight of the evening. It's our pleasure to welcome Mr. Akila Induranga, a software engineer at WS2O, who will be conducting today's session on web development. Sir, over to you.
Yeah, thank you, Malik. So I hope I'm loud and clear. Please let me know if it's not. Yeah, so I'm Akila. So I'm actually from the class 2018 of our college, and then I graduated from the University of Moratuwa, the Department of Computer Science and Engineering, and currently I'm working as a software engineer at WSO2. So let me share my screen. Get started. Hope you can see my screen. Hope you can see my screen, right? Please let me know otherwise. Okay, so we'll start about the fundamentals of web development. Like this will be guiding you about the fundamentals you should know before you start actually coding or anything. So what aspects you should have a look at, and what aspects you should know before starting any of the codings, mainly in the architectural perspective and security and deployment and stuff. So we'll get going. So these are the main areas I'll be covering today. First, what actually is the web development, and mainly the architecture of the web and how these are structured. Web applications are designed using APIs and databases, and then a few facts about security and front-end development, and then platforms where you can host a website, and followed by a brief Q&A session. Okay. Yeah. So what is actually a web development? So it's the process of not only the coding, it's the process of designing, building, and maintaining websites and web applications. So when you have a solution to present, and you present to the public or the clients, so you should have a way to bring and present this stuff. So that's where mainly a web development comes in. So these days, with the internet has been kicked off, everything runs on the web mostly. So most of the applications runs on the web. Not much of the standalone applications are used these days. So that's where the web development comes in. So it's actually the process of designing, building, and maintaining all these solutions. So there we can see a few sub sections as I have highlighted here. So we can mainly see front-end web development and back-end development, and inclusion of these both called a full stack development. So front-end mainly focuses on what the user will see, the user interfaces, how it's going to look and how it's going to feel to the user. And the backend development mainly going to be focused on how we handle the logic, the actual solution, how it's going to run, and how do we store things, how do we make them talk to each other, like the server, where it is where do we gonna host them, the websites and stuff. So that's where the backend development. The full stack development, as I said before, it's kind of inclusion of these two. So you have to know about both of these field areas to be a full stack developer. So I have explained the front end, back end, and full stack development here. So it's kind of if you are going to present a solution, so you should have somewhat understanding of these both parts. Moving on. So now we know that we have front end and a back end for a web application. So how this gonna work? So that's where this architecture comes in. So this is the client server architecture, is the most commonly seen architecture in the web today. So how that's work is the client is, there are two parts in this architecture, as the name suggests, the client and the server. So client is the one, the browser or the application that the user interacts with. If you are going to a website, the browser you're gonna visit, like the Chrome or Firefox, so that's gonna be a client. If you are open an application on your phone, so the phone and the application is going to be the client. That's mainly the idea of the client, where the user interacts with. That's one end of your solution. And the server is the one where the heavyweight happens. So it handles all the logic and the data. So that's where the processing going to be and the storage going to be. So if you are going to visit a website from your computer, the browser will be the client, and it asks a server somewhere in the world to the information you are requesting. So then the server processes and finds the data for you, and you get back the data to the client and you see it. So that's mainly the client server architecture. So to client and server to communicate, we need a network. So the network is pretty much taken over by the World Wide Web. It's powered by the internet, what we called like it's kind of the revolution these days. So everything is on the internet and the World Wide Web. So that's kind of makes it easy for us to build client and servers and make them talk to each other. So and over the internet network, we use the HTTP or HTTPS protocols to make these clients and servers talk to each other. That's kind of like the median or the language for the clients and servers to talk. So that's the main idea of this client and server architecture. I hope you get a brief idea. Yeah, this is a visual representation of how all this works. So as I have said before, we have the client as a browser, and we have a server where the client requesting information is stored on. Then the client is requesting through the internet from the server using the HTTP protocol. Then the server responds back through the internet with the HTTP protocol, the data that the client requested. So if you notice, we have on the request, we have these verbs and methods and stuff. And the response, we have the status code and the data. So that's we call the request response cycle on the web. So this request response cycle pretty much sums up everything about the client server architecture and how the web works. So we leverage this fundamental request response cycle to build our web applications. Based on this, we decide what the client should do and what the server should do, and how we gonna place these client and servers on the network and stuff. So as I said before, based on this request response cycle, we decide how this client and server should behave. So I have listed here some few examples. So there's a 1-tier architecture, 2-tier architecture, and 3-tier architecture. I'll explain them a little bit. So in 1-tier architecture, the client and server are in the same place. So in that case, we actually do not need the World Wide Web to communicate with the client and server. We can simply use the network inside the host. So that means the client and server actually runs in a single computer, if you imagine. So then actually you don't need to have an internet connection. So you can simply use the local host network to communicate with each other. So this can be used to build isolate applications if depending on your requirement, if it's need to be hosted in a restricted environment or something, you can use this 1-tier architecture. Actually, when you are building applications in the development phase, you may be having this kind of an architecture where the host and the client and the server both are hosted in your development environment in the same your laptop or desktop. So that's the one-tier architecture. Then we have two-tier. That's the most common approach we see, where the client is hosted somewhere in and the server hosted separately. So like when you using the browser to access a website, that's mainly the most of the time that's the 2T architecture. You directly communicate with the server and the server directly responds to you. So I think I do not need to explain that very much. And then we have this 3-tier architecture. So we can go up to a number of tiers. That doesn't restrict you from doing that. So from tier 2 onwards, 3, 4, and so on, you can add layers inside between the client and the server. So in 3-tier case, you can have a middleware server. Like middleware means it's sitting in between the client and server. So you can use these middlewares to do various things before the client access the server, like the authentication, or like if you need to add some restrictions, or add some more data to the request, then you can route your client through a middleware to the server and then get a response back. So these kind of things happens in the 3-tier architecture, and you can go up to any number of tiers, basically the layers. So then we have another design decision to be made, should we have a thin client or a fat client? That means the client is basically what the user see and interacts with, but it can have some processing and stuff. So we can decide in our design phase whether we should include these processing parts inside the client or not. If so, this should be decided based on what kind of logic you have, what kind of performance are you expecting. Like if it's a very simple application where the simple minimal UI or the user interface and some data fetching is enough, so you can go with a thin client. If you are expecting some heavy processing to be done, your server can get overloaded. Like server may get too many things to process, so then your clients may see client may see your application is slowing down. So if you have that kind of processing, it's better to go with the fat client, where we have some processing parts overloaded to the client itself, and we handle the data storing part and stuff on the server. So in that case, you need to consider like what kind of clients are you expecting as well, because if it's if your client's going to be a mobile application, you may not be having that much of processing power in those clients, so you need to consider these stuff as well. So anyway, that's another design decision to be made as a fundamental within the client server architecture, whether your client to be thin or fat. So I hope you got an understanding about these things in this about this client server architecture. Then we'll talk about the APIs. When we're talking about APIs, they are actually the APIs are actually the ones let the application talks with the server and stuff. So as you can see in the picture, and as we have discussed before as well, the client and the server, client and server communicates through the internet. So through the internet using these HTTP protocols. APIs are the ones where the data transformation happens, where this where API is the one that says, okay, this server has this kind of information. If you are a client that's going to be accessing this data in the server, you need to have this kind of structure, and we will provide this kind of structured data to you. Likewise, so if it's a simple, let's say if it's a simple API, like you need to get the weather details of the next hour. So if the actual API is gonna look like, so API is gonna look like the client should tell the API, I need the weather data of this date of this hour, and the location is this. And API is gonna take that input and get the necessary data processed at the server, and then responds the application of the client saying at this hour it's gonna be raining, and the temperature is gonna be this much of Celsius, and wind speed gonna be this. Likewise, the structure of how the communication happening is specified by the API. So the structure of the communication is defined by these APIs. So it not only can, it's not only the getting the data. If you're going to write something at the server, like uploading a file or changing a date of birth of your profile, all of this goes through the API. It provides a unified way of how the communication should happen. And the server communicates with the database if it's data storage or retrieval. Otherwise, it's gonna process the data at the server itself. So I hope you have got an idea about how this APIs are working. If not, we'll discuss more in the Q&A session. Yeah, let's move on. Okay, so APIs, when it comes to APIs, it can have several types of APIs. If I'm to name some, we have this GraphQL or the gRPC or the REST. We'll talk about the REST APIs here because it's the most common one, and most of the web applications are using these REST APIs rather than the other categories. So the REST APIs stands for the representational state transfer APIs. So what that means, the API represents a transaction of the data between the server and the client. So server knows nothing about the client, or like server doesn't know whether this is a client that have asked me anything before. Likewise, server knows nothing about the state of the client, whether we have communicated before or like that. That's the what the property we call the stateless. So the API only represents the state of the API communication at the time of communication itself. That means API only knows this client have asked this, and I am responding this kind of data to the client, and then the API forgets about it. So the server knows nothing, the client gets the data, and the client then doesn't know anything about the transaction afterwards. And REST APIs uses this HTTP protocol. There we have several kinds of methods or the verbs, namely like get, post, put, delete, and there's few others as well like patch and stuff. So what that means during the communication we are mentioning this API communication is to get some data from the server, or we mention this API communication is to write some data on the server. This communication is to edit some data on the server or delete some data from the server. Likewise, we have several methods that describes what this particular API communication does. Also, this during this API communications, we are transferring data either from client to server if it's a write or edit call, or in the vice versa as well. We some API calls transfer data from server to client upon the request when it's a get request or something. Like if you have asked for the weather data, the server sends some data to the client. So this data can be in JSON or XML formats. We mostly use the JSON format nowadays. It means we have standardized the structure of the data so that the API have a unified way of representing them. So this is another one example I have mentioned, and I have explained it as well. So if you consider this weather API, so you can the data format of the get weather data API should can be like we are giving the date and the time and the location as the input to the API, and the API gives back the weather data in the format in the predefined format, like the status, whether it's going to raining, when it's going to be raining or not, the temperature and wind speed and etc. So that's how the REST API is going to work. Hope you have got an understanding about that as well. Okay. Then we have this databases. So we had the client requesting data, and we had the server processing the data. The databases are the ones that stores the data. So this also might be useful when you need the data to be stored in the long run, or otherwise you can have it on the server itself. But if you are working with a large number of data which are to be stored for a longer period of time, it's better to have a database in your web application solution. So we have two different kind of databases, namely called the relational and NoSQL, or the document based ones. That means the relational databases store data in the tables, and we have some relationship between those tables. For example, if we have consider a database designed for a school, so you can have a table of students, and you can have a table of teachers. So in the table of students, you can have a column specifying the subjects that the students do, and in the teachers table you can have a column specifying the subjects that the teacher is teaching. So the subject is the column where the relation of this student and teacher represents. Likewise, the relational databases have tables and the relationships. So it's very structured, and also one drawback is it's gonna be a huge number of tables when you have a huge number of relationships. So it's easier if you it's ideal if you have many number of relationships to use a relational database. Otherwise, even if you have a weaker relationships, having this kind of table-based architecture is not very ideal, because it's usually these relational databases needs a lot of computing resources. So in that case, the NoSQL or the document-based databases might be ideal. The examples I have specified here, like the MongoDB, we have Redis as it's kind of using as a database as well. Or we have document DBs and Cassandra and etc. Like for the NoSQL databases, they store data as simple documents. We don't have any table-based architecture. So if you need to store the simple data, you can use this kind of a NoSQL database. It doesn't prevent you from using a relational database, but it's again a design decision you have to make before you start coding and stuff. What kind of database are we gonna use? What kind of data are we expecting and stuff? So I think we have mentioned some facts to consider when you're selecting a database. Like you need to consider what structure is my data gonna be, and what kind of relationships, if there are any, what kind of relationships between this data is gonna be, and how will my server need to get this data queried. Queried means like find, and how the client will access this data, and how much of performance we need in between client and server. So based on these factors, you may need to find you may need to choose a suitable database. It may be the SQL or relational or a document-based database, doesn't matter. So I hope you had a good understanding about a brief understanding about how the databases work and what kind of database you're gonna need for your solution. Okay, so far we have discussed a bit about what fundamental design decisions should make to get started with our project. So with those things in mind, you can start your design and development, but it's not gonna be a production ready like solution. Like you cannot present this solution just as it is to the public or the users for your clients to use, because the web is and it always has been kind of a dangerous place, because its users are always gonna get hacked. Your website's always gonna get hacked. So you need to make sure your solution has some security in place, Otherwise, your users gonna be frustrated about the solution and they will no longer be using it. So we have mentioned here some common threads you can find in the web. So this applies to most of the web applications as well. If I were to go on the list, so the SQL injection, it means like if you are using a relational database within your solution, the user, an attacker pretending to be a user might inject some SQL or the language that the database understands, and they can do some manipulation of the data you have inside the database. So this may include extracting the passwords of the user or the personal information of the users. So we have seen things like that in the recent past. Some user data getting leaked of the web solutions. So you don't need to happen that with your solution. So yeah, the cross-site scripting also kind of same theory. So an attacker pretending to be a user can introduce some code script or a code to be run within the client or a server, depending on how you have connected your solution. So these codes might be running on the client or the server, and attacker can exploit them to extract data or do some dangerous operations on your server. So you need to have security measures in place. We'll discuss what the security measures you can do to prevent these code and data attacks. Another one is the denial of service attacks, or the DOS attacks. So what that is means some web solutions we have exposed to the public. The users, some attackers can send huge amount of traffic to these solutions, and your servers may get overloaded, and then your the original clients might not get the expected behavior of your solution. That means like your legitimate clients are not serving as expected, so the service is denied simply. So that's what the denial of service attacks mean. Also, we have this man in the middle attacks. That means since the web is since we assume the web is extremely insecure, so some attackers can sniff the requests that the legitimate clients are sending to your servers. So they can sniff the request and sometimes impersonate the legitimate clients, or intercept the data, and they can do these various kind of things. So that's a few facts about the security threats in web. So we need to make sure we don't let the attackers exploit these threats within your web solution. So to do that, we can follow this. This is very few steps you could take of simple steps. We have mentioned that the protocol we used in the web is HTTP. So HTTP is extremely insecure protocol. Anyone can see the traffic, the data transferring in between the clients and servers using HTTP. So if we can use the HTTPS, the secured version, then we have some security in place. What the HTTPS does is it actually encrypts the data transferring between the client and server. So if anyone to sniff out or intercept the data, they actually cannot read the data and get a meaningful idea about what this data might be. So if we can use the HTTPS to encrypt the data, it's a must-have. Also, you can have proper authentication and authorizations if you are tackling with the user base for your application. If you expect the users to log in and do some operations, always make sure these users are properly identified, like the authenticated, and then they have only the necessary permissions to do stuff within your web solution. Otherwise, anyone can log into your solution as an admin user and then delete anything or modify everything and stuff. So if you have that kind of user base, it's better to have a look at how the identity management is done securely. Also, we have this API management. We talked about the APIs. APIs are the ones exposed to the client on behalf of your server. So these can get exploited. Like if someone to send a huge amount of traffic to a particular API, it might get denied as your server overloads. So you need to have proper API management measures in place. Like if the same user sending huge amount of traffic, you can block that particular user for a particular amount of time. Likewise, you can do those API, you can manage those APIs in that level of detail. So you can consider this stuff as well. And the input validation, this particularly prevents this SQL injections and the cross-site scripting attacks we have talked about earlier. So always, if you have some forms or forms to submit in your web application or some input boxes for your web solution, always validate your input before executing anything or before sending them to the server. Otherwise, users can inject some malicious code, malicious SQL commands, and they can use this input box as a backdoor to get into your server. So likewise, you can secure your solution. It's a must-have before your application goes to the production ready level. So after the development done, make sure these security measures are in place. Then I'll talk a little bit about the fundamentals of the front-end development. We are not discussing any code level details here. So front-end is the one the user the client's gonna see. So mainly they are developed using this HTML, CSS, and JavaScript languages. So these are three different language. Actually, CSS is not a language, but structure of styles. So what happens is HTML language defines how the web page for the client is organized, what kind of elements are there in the client website. It's defined by HTML. Hope you already know to some extent about this stuff. The CSS defines how these elements are styled, or how the user sees these elements. And the JavaScript defines how these elements interact with each other and how these elements as a whole, front end talks with the APIs and the servers, etc. So if your project front end is going to be implemented using these main basic three languages, I think you're gonna be hassling a lot. But the HTML, CSS, JavaScript are the main place to start as a front-end developer, because it lets you get an idea about how actual the web pages structured and how they work. But if you are to implement a large solution with a huge number of pages and stuff, it's gonna be a hassle. So that's where we have some frameworks to make that easier, make the front-end development easier. So I have listed some of the frameworks here. You may have heard of few. We have the React, Vue, and Next.js and stuff. So these frameworks I have categorized into few subcategories based on how they perform, how they work under the hood. So we have this server-side rendered, and mainly the server-side rendered and single page or the client-side rendered applications. That means think of it as mainly the server-side rendered applications are very thin client. So most of the processing is done at the server, and the basic only the view that the user should see is at the browser, nothing else. Single page applications is kind of a fat client because it has all the logic how to render the remaining of the application is available at the browser. So only the data and the logic is at the server. The whole web pages, the whole set of web pages are at the browser. So that's how this single page or the client-side rendered applications are behaving. So some of them are popular single page application frameworks are this React and Vue.js. And we have the hybrid approach as well, using Next.js like frameworks. You can either tell this part of this application should be rendered at the server, and this part should be rendered at the client, and likewise you can have some flexibility over it. So this is how basically client side and server side application rendering is differ from each other. When the user is requesting website in the client side rendering, the whole logic to render the application user interface is sent to the client, and client is responsible to understand it and show the user what he navigates to. In the server side rendering, the server only sends the requested web page, and the client is going to navigate to another page by clicking a button or clicking a link or something. That request has to go to the server, and the server should respond with the new page that the client needs. Likewise, that's how the server side and client side rendering difference from each other. Okay, I thought I'll talk about this a little bit as well. So following this previously discussed design decisions and resources, you can finish up a working product as your web solution. Now you need to present it to your users or clients. So how do we do that? You cannot give your development laptop for the client to use. So you need to have your web solution published to the internet. In other words, hosted in the internet. So you can use these resources to host your website. If it's a static website, that means like not much of the interactive things, you can use the GitHub pages to host your website. If your solution is mostly a front-end application with a little bit of database calling and stuff, so you can host these front-end in Vercel or Netlify or these kind of platforms. And for deploying the full stack applications, you might want to go with AWS, Microsoft Azure, or DigitalOcean, or some that kind of platform. To host a database, you can use again the AWS. So in simple, you can use the MongoDB website to host a simple document-based database, and then connect it with your front end or server as required. So that's how you host your web solution. And this DNS might be needed if you want to add a custom domain for your website. Like when you host on the Vercel or Netlify, you will be given like very random URL to access your application. If you want to add a URL as your liking, so you need to set up DNS and domain linking and stuff. So have a look at that. It's not that complex. But what I wanted to say is this stuff you can do as you go on. So you can start simple and host your website in a simple manner, and then you can work on as you go on based on the requirements. You can either change or either scale up how you gonna host your website. So that's what I wanted to cover about the fundamentals of web development today. If you have any questions, we'll be happy to answer. Yeah, we'll give a few minutes to Q&A. I think my presentation is done here. We can hand back to the computer site, right?
Thank you very much, Mr. Akila, for that very informative and engaging session. To conclude today's program, I'd now like to invite Tushan Nair, the Secretary of Computer Society, to deliver the vote of thanks.
Good evening, everyone. As we wrap up today's session, I would like to take a moment to extend our heartfelt thanks to all of you for being a part of second TesserX workshop. First and foremost, a sincere thanks to our speaker, Mr. Akila Induranga, for conducting such an insightful and engaging session on web development. Your expertise and practical knowledge you have shared today will empower our participants as they move forward in shaping their ideas into working solutions. We truly appreciate your time and contribution to this initiative. To all our participants, thank you for your enthusiasm and active involvement. Your passion and commitment are what drive TesserX forward. It's inspiring to see you, young innovators like you, taking bold steps into the world of technology and problem solving. A special note of appreciation also goes to the All Royalist Engineering Professionals Association. Your dedication behind the scenes is what makes sessions like these possible. And before we wrap up, a quick reminder. Our next workshop will be on entrepreneurship, how to pitch your ideas and shape them into real-world solutions. And we will be excited to see you all as there as well. Thanks again, and see you at the next session. You may leave now.